Assalamualaikum warahmatullahi wabarakatuh, brothers and sisters. Welcome to Physics Clinic 2.0 for Physics 1 subject. I am Nur Azuni and I will be your host for today's event. So, let us start our event with Doa recitation from Brother Ahmad Fawaz.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Al-Fatihah. A'udzu billahi minasyaitonir rajim. Bismillahirrahmanirrahim. Alhamdulillah rabbil alamin wassalatu wassalamu ala asyrafil anbiya wal mursalin wa ala alihi wa sahbihi ajma'in. Ya Allah, Ya Rahman, Ya Rahim. Praise be to Allah, the Lord of the world. Peace and blessings be upon our Prophet Muhammad sallallahu alaihi wasallam and his companions, for those who followed his example till the judgment day. Allahumma ya Allah. On this blessing morning, in conjunction with the Physics Clinic 2, we beseech thee, grateful toward you in favor of all the infinite blessings to us, your humble servant, to live in safe and prosperous life. We seek your blessing for the flawless progress of this event from beginning till the end. We seek your guidance to stay clear and of event that would detrimental the progress of this event. Ya Latif, Ya Rahman, please bless us with your tawfiq and hidayah. Please guide us to greatness, peace, glory, and prosperity in this world and the hereafter. Make us responsible intellectuals. Grant us with valuable knowledge that will be beneficial to mankind in order to gain your mardatillah. Make us your righteous servant that followed your commands and neglect the sinful act. Please forgive us for our wrongdoing. ربنا عليك توكلنا وإليك المصير. اللهم افتح علينا حكمتك وانشر علينا من خزائن رحمتك يا أرحم الراحمين. ربنا اشرح لنا صدورنا ويسر لنا أمورنا واحلل عقدة من ألسنتنا يفقه أقوالنا. اللهم ارزقنا يا فهم يا ربي وحفظ المرسلين وإلهام الملائكة المقربين بالعافية يا أرحم الراحمين. ربنا ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار. وصلى الله على سيدنا محمد وعلى آله وصحبه وسلم والحمد لله رب العالمين.
Amin Amin Ya Rabbal Alamin. Now, without further ado, it's time for us to move on to the main cause of this event. If you guys have any questions throughout this lecture, you can write it on the comment YouTube section. Therefore, let's give a very warm welcome to Madam Sharifah Fazlon binti Said Hussein, our respected speaker, to give her knowledgeable lecture.
Assalamualaikum. Can you hear me? Okay, all right. Okay, Bismillahirrahmanirrahim. Okay, I'm Madam Sharifah Fazlion binti Syed Hussein. Okay, so I will soalan ni bergema sikit. Ada echo. Alright. Boleh dengar clearly tak? Sebab Madam dengar suara Madam. Wait ya. Okay, alright, clear. Okay. So, okay, semua dengar? Okay, dah tak ada echo. Alright, alhamdulillah. Okay. So insyaAllah, okay, we will discuss today, okay, about the topics covered in Physics 1. Okay. Okay, I introduce myself again. Okay, I'm Madam Sharifah Fazlul binti Syed Hussein. So in this semester, I taught Physics 2. Okay, but I'm willing to give talk on Physics 1. Okay, for this semester. Okay, as a preparation for the final exam. Okay, insyaAllah in 2 weeks time. Okay. Alright, so we begin without further ado. Okay, we begin with topic dimensional analysis. Alright, so this just I am preparing 2 questions. Okay, just to give a start. Okay, with topic 1 because you have been because dah sekian lama. Okay, you tinggalkan topic 1, isn't it? Right, so we just to refresh back. Right. Okay, so the first question. Each of the following equations was given by a student. Which equation can't be correct? Okay, so how to check the correctness of a question? All right, so to check the correctness of the question, okay, wait here. All right, so what you should do, okay, so we are going to apply dimensional analysis, okay, to the to this, isn't it? All right. So to determine the correctness of the equations. Okay, by the way, you can interrupt me. Okay, if any question you want to ask, okay, spontaneously, you may ask, right? So how to check the correctness of this equation? V equals to KU plus AT squared. Okay, V equals to U plus AT squared, all right? Okay, how? So here we have left side of the equation and the right side of the equation. All right. So according to dimensional analysis, okay, we have to ensure that all these quantities must have correct dimension, isn't it? Okay. So as for at the left side of the equation, okay, it is the velocity where we know that the velocity in the left, okay, L stand for left, right? Okay, so V is the velocity and the dimension is L over T, isn't it? L over T, right? So to determine, to ensure that it is correct equation, we must make sure that U also has the same dimension, isn't it? All right, so U is also velocity, the dimension is L over T, all right? So how about AT squared? Okay, so to AT squared, okay, we know that the dimension is for acceleration is, anybody can tell me? The dimension of L? Sorry, the dimension of acceleration? Anybody? Acceleration. What is the dimension for acceleration? L over T squared. All right. And the dimension of T is T squared. All right. So this one, secara algebra dia, okay, we have that AT squared has dimension of L. All right. Jadi you can see that from here. Okay, this is L over T. This is also L over T. But for AT squared, the dimension is L. All right. So meaning that the third parameter here, AT squared, has different dimension, isn't it? That is equals to L. So this is not correct. Okay, by using dimensional analysis. Right. How about part B? Okay, part B. Okay, to ensure that it is correct. Okay, V equals to AT. All right. So this is L over T. Right. So the acceleration is L over T squared. And then here is T, isn't it? All right. So cancel T. Okay. So we have L over T, isn't it? All right. So from here, the right and left equation, okay, has same dimension, isn't it? All right. So V equals to AT has the correct dimension. Sorry, correct equation. All right. Can you follow? Okay, let's go through the second equation. The second advantage of using dimensional analysis. Okay. All right. So what do we have here? Okay, the displacement of an object. Okay, we go. All right. So the displacement of an object moving under uniform acceleration is some function of time and the acceleration. Okay. So suppose we write it as, okay, can you hold on for a second? All right. So what do we have here? Okay, we have the equation is S equals to, okay, K A to the power of M and then T to the power of N, right? So this is displacement, right? And at the right side of the equation is K A to the power of M, T to the power of N, right? So what are we going to find here is to find the value of M and N. Now in question like this, we assume that the equation is correct. Okay, kita assume equation is correct, alright? Okay, equation is correct. Okay, can somebody respond to me because I'm afraid that I couldn't hear the audience voice. Okay, I see. Okay, okay. All right. Okay, thank you. Okay, so the equation is correct. So first, we assume that the equation is correct. All right, and then at the right side of the equation, okay, at the right side of the equation, we have, okay, K A to the power of M, okay, and then T to the power of N, right? So we know that if the equation is correct, then we must ensure that, okay, the dimension, okay, of S, okay, must equal to the dimension of K A to the power of M and T to the power of N, isn't it? All right. So let us find the dimension of at the right side of the equation. All right. So K mentioned here, K is a dimensionless constant. Okay, meaning we can ignore the dimension of K because it is dimensionless. K could be numbers, isn't it? Okay. Now A is acceleration. Okay, because of the word here, acceleration. And we know that acceleration has dimension of L over T squared. Okay, and then to the power of M. Okay, and then for T, time, okay, dimension is T, okay, to the power of N. Right, so we are going to solve this, all right, first. Okay, so we have L, okay, L to the power of M. We may bring up T square, okay, like this, T to the power of negative 2, okay, and then times dengan M, right? So negative 2M, right? And then we have, okay, T to the power of N, right? So we are going to rearrange it. So we have L to the power of M and then T, okay, negative 2M plus N, okay, plus N. All right. So this is the dimension of the right side of the equation, right? All right. So we have this equation, okay? And at the left side of the equation, okay, at the left side of the equation, we have the displacement S, right? And we know that the dimension of displacement is equivalent to L, isn't it? Okay. So the next step, okay, is, okay, the next step is to equate these two, isn't it? Since they have same dimension, right? The right side, okay, of the equation, okay, here is the right side of the equation, all right, must have the same dimension with the left side of the equation, right? So we equate these two. So we have L equals to L to the power of M, okay, and then T to the power of negative 2M plus N, right? So here we have L to the power of 1. We can write 1 here, isn't it? Right? But how about T? Okay, so dekat sini we can write T to the power of 0. because anything that has power of 0 is equals to 1, isn't it? Okay, we may have 1 to the power of 0 equals to any quantities, any numbers. Okay, 2 to the power of 0 equals to 1, right? So anything that has the power of 0 equals to 1, isn't it? Right? So we can compare, and from the comparison here we have that m equals to 1, isn't it? Okay, m equals to 1. All right. So you can write m equals to 1, and then we have the other one, negative 2m, plus n equals to 0, right? Equals to 0. So substitute m with 1, we have plus n equals to 0. So end up we have n equals to 2. All right. So by using dimensional analysis, we have already found the values of m and n. So therefore, the equation can be written as S equals to k a to the power of 1, and then t to the power of 2. Or we can write S equals to k a t squared. All right. So since k is dimensionless, so we don't have to find the value of k in this question. All right. So these are two questions, examples on dimensional analysis. Okay. So next, I am going to share with you, the second topic, about motion in one dimension. Okay, so in physics 1, the chapter 2, chapter 3, and chapter 3 is basically about mechanics. And the mechanics begin with the motion. Motion in one dimension. All right. So let's go to this table. So I have we can summarize the motion ataupun mechanics by this table. All right. Okay, so in motion, we have two types of motion. We have one-dimensional motion, and we have also two-dimensional motion. All right. So how to analyze, the motion? So to analyze the motion, we can first we need to know several terms, isn't it? All right. So we have displacement. Displacement. All right. So I can write here. Displacement, known as x, isn't it? Known as x. All right. Generally, yes, displacement is s, isn't it? Secara general lah. Displacement is s. All right. But if the object is moving along x-axis, all right, we substitute s with x, isn't it? And then we have velocity. We have velocity. All right. So the velocity is defined as dx over dt, isn't it? All right. And then we have the acceleration. Where we define the average acceleration as dv over dt, isn't it? All right. Ataupun sometimes we may write a equals to delta v over delta t, isn't it? Also can delta v over delta t, where delta v is the change of the velocity. It is known as v final minus v initial. V final minus v initial, right, over delta t. And how to analyze the motion? So to analyze the motion, we use kinematic equations where we have v equals to u plus at, the kinematic equations, right? So all these equations are given in the final exam, isn't it? All right. So v squared equals to u squared, plus 2a delta x. And we have delta x equals to v u squared, ut, plus half at squared. All right. So for the terms, in your textbook, the initial velocity u, is indicated by vi, isn't it? All right. So you can use u, or you can also use vi. Right. Now, How about when the object is moving along y-axis? Okay, so along y-axis, meaning now we are going to substitute the displacement with y, isn't it? Okay, y, free fall. Okay, for example, free fall, the object is going downward, isn't it? Downward. So what to do with this equation here? Okay, there is one thing that you need to know. Okay, if the object is moving vertically, all right, so the acceleration, okay, is equals to negative g. Okay, this is one thing that you need to know. A equals to negative g, right? So therefore, the mechanic, okay, the equations used will become, okay, v equals to, okay, u minus gt, isn't it? Okay, minus gt, meaning the same kinematic equation is used, all right? And then here we have v squared equals to, okay, u squared, okay, minus, okay, 2g, instead of delta x, now it become delta y, all right? Okay, and then here you have, okay, delta y equals to, okay, uyt, okay, uyt minus half gt squared. All right, minus half gt squared. Okay, do you need to remember this equation? Okay, you don't have to. Okay, you just remember the kinematic equations that will be given in the exam, isn't it? Right. So the concept here is that just change, all right, the acceleration into negative g. All right. And for free fall, of course, okay, the displacement is indicated by symbol y. All right. Okay, ini kalau straight motion. Okay, so for 1D motion meaning one straight motion. All right, so this is straight motion. Okay, meaning to say the motion is either along x-axis ataupun y-axis. All right, this straight motion. All right, for 2D motion, okay, 2D is also known as projectile motion, isn't it? Okay, projectile motion. Okay. Okay, in this case, all right, we have three types of projectile motion. Okay, I am not going to write, okay, but just remember the types of motion by diagram. Okay, first we have diagram like this, isn't it? Okay, like a hemisphere. Okay, like a hemisphere. Okay, and then the other one, okay, we have projectile motion like this. Okay, where we have, okay, the object is moving. Okay, meaning to say when you throw the object, okay, it will land on a different level. Okay, different level. And the other one, we have horizontal projectile motion like this. Okay, meaning initially the object is moving horizontally and then going down. All right. Okay, so what equation that we are going to choose here? Okay, so here the kinematic equations will be divided into two components. Okay, into two components, meaning to say, what do we have here? Okay, we have, okay, for equation v equals to u plus at. All right. So for example, untuk for equation v equals to u plus at, what will it will become? Okay, we have vx equals to ux. Okay, plus axt. Okay, plus axt. All right. For y component, we have vy equals to uy plus ayt. All right. So, but with one exception. Okay, no matter what type of the projectile motion, okay, for all these three, all right, ax is equals to 0 and ay equals to negative g. All right, regardless of the type of the projectile motion, always remember that in projectile motion, okay, the object will move under influence of gravity. All right, so the acceleration involved here is only because of gravity. All right, so ax equals to 0. So for this component, x equals to 0. So meaning that throughout the motion, vx is always equals to ux, meaning from the beginning, okay, we know that the velocity has become two component, isn't it? So we have ux, we have uy, okay. So throughout the motion, all the x component will have same velocity, isn't it? Okay, same velocity, right? Until it falls down here, meaning vx, the x component of the velocity remain the same. The same also happen here, isn't it? So here you have, okay, ux, all right, ux here, all right. So meaning to say the horizontal component remain the same of the velocity vx, okay, vx remain the same. The same also happen here, isn't it? Okay, so for this type of motion, ux equals to 0. Sorry, we have ux. So throughout the motion, okay, vx remain the same until until it fall down here. Okay, meaning the x component of the velocity remain the same. Okay. Now, how about ay? Ay we substitute with negative g. Right? So the same also follows to the other two equation as well, right? Okay, for example, let's say I choose this one, s equals to ut plus at squared, right? S equals to ut plus half at squared. So this equation will be break down into two components, component x and component y. So here we have delta x equals to kuxt. Okay, because ax equal to 0, so it stop here lah, right? And then for delta y, we have delta y equals to, okay, uyt minus half gt squared. All right, so there is no more ax. All right, so for v squared equals to u squared plus 2as. Okay, this one I want you to try by yourself later. Okay, this one also will be break into two components. All right, so this is some summary of projectile motion. So let me show you, okay, how to tackle, okay, question on projectile. Okay, let's go through one example here. Okay. Now, okay, a ball is thrown vertically upward with a speed of 25 meter per second. Okay, a ball is thrown vertically upward with a speed of 25 meter per second. A, how high does it rise? All right. So how to tackle this question? Okay, thrown vertically upward, meaning to say, okay, if you want to draw the motion diagram of the ball, it will be something like, okay, kalau vertically upward, so you can draw something like this, isn't it? Vertically upward. Just draw an arrow, right? Vertically upward. Okay, so what do we have? Okay, something like this. Okay, thrown vertically upward. Okay, with a speed. Okay, with a speed of 25 meter per second. So this 25 meter per second refer to the initial speed, isn't it? Okay, u ataupun vi, okay, equals to 25 meter per second. Okay, how high does it rise? Now, from the word vertically upward, okay, vertically upward, meaning this is a straight line motion that is along y-axis. Okay, so but it won't be, kita kata apa, when we throw it vertically upward, after one time, okay, once it reach maximum height, dia akan momentarily stop, isn't it? Let's say this is the maximum height, okay, it will momentarily stop. After some time, dia akan going down, isn't it? Okay, so this is one example of free fall. All right. So the question is, how high does it rise? Okay. So there is one thing that you need to know. At maximum height, okay, the speed will be equals to 0, right? At maximum height. Okay. So to solve part A, how high does it rise? Meaning we are going to find the displacement delta y, isn't it? Okay, delta y. Okay, and we choose the initial point as y equals to 0. Right? So nak cari delta y. Alright, so how? So to find delta y, okay, so we can use any, you can choose any three kinematic equations. Okay, so let's say just try and error. Okay, let's say I choose this one, v squared equals to u squared, okay, plus 2as. Okay, I start from scratch. Okay, mula daripada, meaning kata kita ambil kinematic equation yang asal. Okay, v squared equals to u squared plus 2as, right? So we know that at maximum height, v equals to 0. So just substitute 0 here. Okay, and then u equals to 25. So we have 25 squared, right? Substitute into here. Okay, plus, okay, 2. So what is the value of a that we are going to put here, right? So it is free fall, isn't it? Free fall. After some time, dia akan jatuh ke bawah. Okay, it fall down. Why? Because of gravity, isn't it? All right. So therefore, the acceleration here is under influence of gravity. It is equals to negative g. Why negative? Because gravity is always pointing downward. All right. So we have negative g ataupun negative 9.8. Okay, and then as here, displacement here is along vertical axis, right? So this is delta y. So this, from here, when you calculate, you will get delta y equals to, okay. So when you calculate, all right, okay, you must consider the positive and negative number. All right, 25 squared, okay. You divide by, okay, 2 times 9.8. So you get 31.9, okay. So you get positive, isn't it? All right, 31.9 meter, okay, positive. All right. Okay, so the logic are positive. Kenapa? Because it is going upward, isn't it? All right. Okay, B. How long does it take to reach its highest point? So meaning how long? Okay, meaning nak cari time, isn't it? Okay, so nak cari time, so we choose kinematic equation yang ada sebutan T, isn't it? Okay, let me choose, okay, let's say V equals to U plus AT. Okay, U plus AT. Alright, so to reach highest point, we know that at highest point V equals to 0. Alright, so U is 25. Okay, A is negative 9.8, isn't it? Okay, negative 9.8, and then T. Alright, so T equals to, now bear in mind, okay, T must always be positive. Okay, let's say when you do the calculation, you get T negative. Okay, so you must check once again because T cannot be negative. Alright, so here you will get 2.55 second. Right, in case katalah you buat calculation, you dapat T negative, so you must check. Okay, sometimes maybe you tak letak negatif kat sini ke. Alright, so always remember that. Okay. C, okay, how long does the ball take to hit the ground after it reaches its highest point? Okay, how long does the ball take to hit the ground after it reaches highest point? Okay, now here, okay, it seems that, okay, the motion of the ball is symmetry. Okay, is symmetrical. Symmetrical means, okay, first it goes up and then it goes down, isn't it? Goes down, right? So we need the symmetry. Okay, so kalau symmetry, alright, kalau symmetry bermaksud, okay, if it what you call it, if it take 2.55 second, okay, to go up, alright, 2.55 second to go up. Okay, sebab dia symmetry, alright, it will take another 2.55 second to go down. Okay. So the question is how long to hit the ground after reaches highest point, meaning dia dah reaches highest point, So to go back to the ground, it will take another 2.55 second. Alright, so you don't have to calculate. Ni jimat masa, right? So if you know this concept, alright, you can save time, isn't it? Okay, so from here, katalah, okay, let's say I want to find out the total time. Okay, dalam soalan ni tak ada cakap total time, but in case if you want to find total time, right? So to find total time, it will be 2.55 campur 2.55. Alright, 2.55 plus 2.55. 5. Alright. Okay. Next, part D, what is its velocity when it returns to the level from which it started? Okay, so dekat sini pun, okay, kalau you faham konsep, okay, you don't have to calculate. Okay, how? So it goes up and then momentarily stop and it goes down, isn't it? Alright, so dekat sini, okay, if it is thrown at positive 25 meter per second, we know that as the ball goes up, velocity akan makin berkurang, isn't it? Okay, katalah dekat sini 20 meter per second, alright? So let's say here you have 5 meter per second, meaning the velocity is decreasing, isn't it? Magnitude decrease sampai dekat sini dia kosong, alright? So when it goes down, okay, so dekat sini velocity akan jadi negatif, negative 5, okay, negative 20. When it goes back to the ground, okay, dia akan jadi negative 25. Alright, so the velocity as it returns to the level from which it started will be equals to negative 25 meter per second. Alright, nak calculate boleh kalau you faham konsep ni. Alright, so you can just put up V equals to negative 25 meter per second. Same level, same magnitude but opposite direction. Alright, so you boleh buat, okay, same level, okay, same magnitude, okay, same magnitude but opposite direction. Alright, okay, so this is one example of free fall. Okay. Okay, next one. Okay, let's go through one example regarding projectile motion. Okay. A brick is thrown upward from the top of a building at an angle of 25 degrees to the horizontal and with an initial speed of 15 meter per second. So let us draw, okay, a motion diagram for this, okay, for the brick. All right. So we have, okay, is thrown from the top of a building. Katalah ni building, right? And of course, this is the ground, okay? So thrown upward meaning it is something like this. Okay, we have, okay, thrown upward. Okay, so what happened after some time dia akan fall down, isn't it? So this will be the motion diagram of the brick. All right. Okay. So it is thrown with an angle of 25 degree with horizontal. So this is 25 degree, isn't it? All right. So this is 25 degree. So theta equals to 25 degree kat sini. All right. And with an initial speed of 15 meter per second. So we have U. Ni U lah ataupun VI. Okay. So U equals to equals to 15 meter per second. So the question is, if the brick is in flight for 3 seconds, how tall is the building? All right. So 3 seconds is the total time. Okay, given is the total time. Okay, total time. Okay, equals to 3 seconds. All right. So what are we going to do? Okay, first step is to resolve the initial speed, isn't it? All right. So in projectile motion, regardless, okay, whether it is horizontal projectile motion ataupun yang same level or this type of projectile motion, okay, the first thing to do is to resolve the initial speed into x and y component, meaning yang u equals to 15 meter per second ni, alright. So you have to make it, okay, cari dia punya x component, cari dia punya y component. Okay, how? So you nampak tak macam segitiga dekat sini? Alright. So we have something like, okay. So I ambil ni, yang ni macam segitiga. Alright. So this one, okay. So we have something like this, okay. Alright. Okay, so you have, this is 25 degree. Alright, so this is 15 meter per second, isn't it? Alright, 15 meter per second. So this will be 15 cos 25. and this is 15 sine 25, isn't it? All right. And both are positive, isn't it? Okay, kenapa both are positive? Dia punya ux. Okay, this is ux and this is uy. Meaning ux is directed to the right and uy is directed upward. Okay. All right. So we have ux equals to 15 cos 25. Okay. And uy equals to 15 sine 25. Okay, first. Okay. And then, okay, kita nak cari apa? Okay, how tall is the building? Okay, how tall is the building? Meaning, we are going to find this one. Meaning that, as the object is going down, it will go through certain displacement, isn't it? That certain displacement is delta y. This is what we are going to find, isn't it? Right? So cari equation, okay, find kinematic equations yang ada sebutan y. Alright, so let's say I ambil, katalah, because dia bagi t kan, isn't it? So let's say I choose s equals to ut plus half at squared. Okay, ut plus half at squared. Alright, so katalah you macam tak ingat dia punya komponen-komponen, start daripada mula, isn't it? Start from scratch. Alright, so yang ni pecahkan kepada y component. Alright, so we have delta y equals to uyt. Remember, ni jadi setengah ay lah, isn't it? Okay, setengah ay t squared. Alright, so delta y is the one that we are going to find. Okay, uy is 15 sine 25. Okay, and the total time is 3 seconds. Alright, 3 seconds. Okay, plus with half ay must be negative 9.8. Okay, negative 9.8, and the total time is 3 squared. Alright, and then you can find delta y. Okay, so when you calculate, okay, let me calculate first. Okay, sine 25. Okay, sine 25. Make sure your calculator is in degree mode. Okay, students always make mistake. Okay, cara dah betul, langkah dah betul, tiba-tiba jawapan lain, because sometimes you tertukar mode degree dengan radian. Okay, please make sure. Alright, you guna mode yang betul. Alright. Okay, times 3. Okay, equals to this one. Okay, minus. Okay, times 9. Okay. Okay, so when I calculate, I get negative, okay, 25 meter, negative 25 meter. This is not the final answer yet, right? So this is the displacement, isn't it? Displacement, okay? So logic lah, displacement negative. Kenapa? Because it is going downward, isn't it? Okay, your answer should get negative because the object is going downward, isn't it? Displacement is negative. Nampak tak? Dia jatuh ke bawah kan, isn't it? Okay. And the question is how tall is the building, alright? So how tall is the building ni jawapannya dalam bentuk skala lah, isn't it? Alright? So the height of the building is 25 meter. Alright? So the height, mana ada height negatif kan, isn't it? Alright? So height equals to 25 meter. Alright? Okay, there is one question here. Okay, one last question regarding kinematic motion. Alright. Right, a truck covers 40 meter in 8.5 seconds while uniformly slowing down to a final velocity of 2.8 meter per second. Alright, covers 40 meter. Okay, so this is one question of 1D motion, isn't it? 1D motion, okay, meaning the object is moving horizontally, isn't it? Covers 40 meter. So this 40 meter shows the displacement, okay, delta x equals to 40 meter. Ataupun dalam generally it is displacement lah, s, isn't it? Alright. in 8.5 second. Okay, so given is t, okay, 8.5 second. All right. While uniformly slowing down to a final velocity of 2.8 meter per second. Final velocity. So given is the final velocity V final equals to 2.8 meter per second. A, find the truck's original speed. Okay, so in part A, you are going to find the truck's original speed ataupun initial velocity, right? So how? So meaning you nak cari U ataupun nak cari VI, isn't it? Nak cari VI, okay? So just select, okay, the kinematic equations. So katalah I nak ambil equation ni, V squared equals to U squared, okay, plus 2AS. Okay, plus 2AS, alright? Okay, so the final velocity is given, okay, slowing down to a final velocity, alright? So you have 2.8, okay, final velocity, 2.8 squared equals to, alright, U ataupun VI, okay, U ataupun VI, this is the one that we are going to find, okay, plus 2, okay, A kita tak tahu lagi, alright, and then S is the displacement, that is 40 meter. Alright, so we have one equation here, isn't it? Okay, one equation. Okay, but we have two this we cannot solve yet because we have two unknown, isn't it? Okay, kita tak tahu VI, we don't know VI, and we don't know the acceleration, isn't it? So this will become the first equation. Alright, so another equation that we can use is, alright, okay, let's say I want to take okay, S equals to, okay, let's say we have okay, S equals to VIT plus half AT squared. Okay, plus half AT squared. We need two equations to find both original speed and acceleration, right? So here we have 40 equals to, okay, VI, we don't know yet. Okay, T is 8.5. Okay, and then plus half AT squared. Okay, plus half AT squared. T is 8.5 squared. Okay, 8.5 squared. Okay, this will be equation 2, right? So solving these two equations, then you can find the initial speed and the acceleration. All right, so you just substitute, okay, equation 1 into equation 2, or you can use persamaan serentak lah, alright? Okay, that one I leave it to you, alright? But one thing that you need to know, okay, from the word slowing down, okay, okay, from the word slowing down here, okay, we know that kalau dia slow, meaning V final is less than V initial, isn't it? Alright, so meaning to say the final answer for the velocity you will get negative, right? So V final you akan dapat negative, right? Or you can also use, kalau you tak suka bentuk yang ada kuasa 2, right, you may also use V equals to U plus AT pun boleh. Okay, let's say you macam tak suka yang ada kuasa-kuasa 2 ni, right? So you may also use V equals to U plus AT, also can, it's up to you, right? So V, berapa tadi V? 2.8, alright, equals to, okay, VI, okay, plus, T berapa tadi? T is 8.5A plus 8.5A, right? So meaning you can play around with these three equations, okay? Kalau you tak suka yang bentuk kuasa 2 ni, okay, you can also apply antara equation 2 dan equation 3 ni. Alright, so you solve these two, then you can find the answer, right? So the answer is here, okay, already here. So you can try lah, okay, after this, kalau ada masa nanti you nak tengok balik benda ni, okay, you can semak lah jawapan dia. Alright. So this will be some exercises, okay, some questions on one-dimensional and two-dimensional motion. Okay. Okay, wait ya. Alright. Okay, next. Okay, wait, there's something dia hanging pula tiba-tiba. Okay, wait ya. Okay, wait, dia take time sekejap ya. Okay. So next we are going to look at, okay, just now we have motion 1D and 2D. Next we are going to look at force and work. All right. Okay. Force. Okay, forces. Okay. Okay, when we learn about force, okay, we know Newton's law, isn't it? Okay, Newton's law, meaning bila you tengok mana-mana reference book, okay, kalau tentang force, okay, in the earlier parts of the topic, okay, so mesti dia akan discuss tentang Newton's law, isn't it? Right? So first we have Newton's first law. Okay, and L ni I buat short form lah, Newton's law. Okay, the first Newton's law. Right? So the first Newton's law, okay, states that, okay, an object at rest will remain at rest. An object in motion will remain at its constant speed motion unless there is net force acting on it, right? Jadi mathematically we can write, okay, Newton's first law as, okay, net force equals to 0. Okay, meaning the object is as it is. Okay, no external force acting on the object. Okay, and since forces are vector quantity, alright. So yang ni kita boleh kembangkan. Okay, meaning the net force along x equals to 0 and the net force along y also equals to 0. Right? Okay, ni the first one. Okay, the second one, Newton's second law. Okay, Newton's second law states that okay, the acceleration of the object is directly proportional with the net force acting on it. Right? So it has something to do with the force and the acceleration, isn't it? All right. So we have, okay, net force equals to ma. Okay, and it follows that, okay, because forces are vector quantities, all right. So net force along x equals to ma x. Okay, and net force along y equals to m ay. Right? Ini Newton's second law. Okay. Newton's third law, okay, every action has reaction. Okay, every action has reaction. Okay. And then you have something like, okay, F. Okay, for Newton's third law, dia mesti ada two objects ataupun two pairs of object, right? So basically, mathematically, we can write it as F12 equals to negative F21. Right? So ni motion is much related we know that the okay, so force mesti ada work. There is equation W equals to Fs cos theta. Okay, during your school time, okay, you cuma tahu that equals Fs je, betul tak? Okay, wait, I refresh. Okay, wait. Okay, sorry apa? Alright. Okay. Okay, back to the whiteboard. Okay. Alright. Okay, so work is much related to the force. Okay. Okay, so work is much related to force. So although they are at different topics, okay, but I just want to give stress it in in chapter force ni lah, alright, because it is much related. Okay. Okay, so what do we have here? Okay, so work equals to Fs. Okay, during your masa you sekolah dulu, alright, during your school days, you know that work equals to Fs, isn't it? Okay, I think most of you know work equals to Fs. Okay, Fs. Okay, but here, okay, kita kena specify betul-betul, alright. So alright, so force here, okay, meaning that if there is any force, we can find the word that related to it force. All right. So we know that we have many types of forces, isn't it? We have normal force, okay, we have friction, we have tension, okay. We may find the work done from these forces, okay. So if there is work, then we can find, when there is force, then we can find work from it, isn't it? Okay. So here we have Fs cos theta. What is theta? Okay, theta is the angle between the force and the displacement, okay. Right, so theta must always be measured, okay, from the displacement to the force itself, isn't it? Right, so theta, okay. And we can also find work, okay, from okay, I just give you some example, okay, kat sini, right. So we can find something like, for example, kalau you nak cari network, okay, so F kat sini kena apa? Kena net force lah, isn't it? Okay, net force, okay, F net, and then S cos theta. Okay, kalau you nak cari work from gravity, okay, work from gravity, so force kat sini mestilah force of gravity, okay, Fg, and then S cos theta. Right? Okay. And then okay, next we may also wait ya. Alright. Okay, we can also find network from work kinetic energy theorem, meaning we have other alternative, okay, to find network. Right, that is network equals to the change in the kinetic energy. Right, that is half mv final squared minus half mv initial squared. Also can. Right. And the other alternative, we may also find work, okay, by total up, okay, the work from each of the forces acting on the system. Okay, so nanti bila kita buat exercise, I will show to you how. Okay. Okay, besides that, okay, force, work and energy, they are always, dia saling berkait. Okay, force, work and energy. Alright, so dekat sini I just write down, okay, the mechanical energies that you learn in physics 1. We have kinetic energy, half mv squared, and we also have potential energy. Alright, so potential energy ada two types. Okay, we have gravitational potential energy, and we also have spring potential energy, meaning kalau it involve spring, okay, so we may find the spring potential energy. Alright, okay, so let's go through, okay, some problems on how to find work. Alright, so what do we have here? Okay, let's go through this question. A woman at an airport is towing her 20 kilogram suitcase at constant speed by pulling on a strap at an angle theta above the horizontal. She pulls the strap with a 35 Newton force and the friction force on the suitcase is 20 Newton. Okay, first, body of the suitcase. Now, when you learn about force, okay, you must know the force diagram ataupun free body diagram. So how to draw a free body diagram? Okay. So free body diagram is a diagram that lists all the forces acting on the system, right? Jadi dekat sini you kena identify sistem apa yang apa the system kat sini, alright? Adakah the woman or is it the suitcase? Okay, in this case yang bergerak tu apa? Yang bergerak tu adalah the suitcase, isn't it? Alright? Nampak perkataan ni, the friction force on the suitcase. Okay, so this is the suitcase, is towing her 20 kilogram suitcase. Another thing that kita tahu, objek ataupun sistem kat sini adalah suitcase because dia bagi mass of the suitcase, dia tak bagi mass of the woman, isn't it? Right, so yang bergerak ni adalah the suitcase. Woman ni adalah external force that is acting on the suitcase. Alright. Okay, so how to draw the free body diagram? So we draw a free body diagram. So we have, kalau free body diagram, okay, first kita kena ada paksi Y dengan paksi X. Alright. So we have, okay, Y axis and then X axis. Okay, so since the object is moving horizontally, alright, jadi paksi X ni secara horizontal lah, isn't it? Okay, paksi X, alright. And then, okay, what are the forces acting on the suitcase? First, since the suitcase is on the surface, ada physical contact dengan the surface, right? So we have the normal force. Normal force ialah force yang wujud perpendicular to the surface, isn't it? If the object has a physical contact with a surface, alright, so the normal force will be directing upward. Okay, the normal force must be perpendicular to the surface. Alright. And then we have mg. Okay, mg. Okay, the weight of the suitcase. Alright. And then the woman is pulling the suitcase with with a force. Okay, with a force, with a horizontal, with a force. Ada tak dia bagi force tu berapa? Yes, okay. Dia bagi force tu, she pulls on the strap with 35 Newton force. 35 Newton force. And meaning that you have the, nampak tak ni dia punya string macam ni kan, isn't it? Right? So we have this is the third force. Okay, this is the force equals to 35 Newton. Okay, and in the question, okay, dia bagi the angle. Okay, the angle between the force and the horizontal, isn't it? And angle theta. Okay, sorry, sudut dia tak bagi, tapi dia bagi dalam sebutan theta, isn't it? Alright. Okay, so we have theta here. Okay, tak apa. Okay, alright. So what are other forces? Friction. Okay, the friction force is 20 Newton. Now, friction force is a force that oppose the motion, isn't it? Oppose the motion. So we have that the friction force is directed in opposite the motion. So this is the friction force, right? Then the friction force is given 20 Newton. So F sama dengan 20 Newton, right? Okay, so these are the forces acting on the suitcase. The question is draw a free body diagram. Okay, done. Okay, kita dah draw free body diagram part A, right? So part B, what angle does the strap make with the horizontal? Right, nak cari angle. Alright. So untuk nak cari angle, okay, it is better kalau kita buat dalam bentuk table, right? Bentuk table, okay. We are going to pecahkan ataupun divided the forces, all the forces here into x component and y component, right? So mana forces yang along x component, mana forces yang along y component, isn't it? Alright. So yang y component, okay, ialah normal force, right? Kita ada normal force. Mg also lies along y component, but it is in the opposite direction, isn't it? Ini negative mg. Okay, how about friction? Okay, friction is directed to the left. Alright, so ni negative 20. Okay, how about this 35 Newton? So this 35 Newton, it is like in between, isn't it? This 35 Newton, it has two components. It has x component, okay, 35 cos theta, and it also have y component, okay, 35 sin theta. Alright, both are positive, right? Okay, both are positive. Okay, so we have that. Here we have 35. So letakkan mereka dalam kategori masing-masing. Okay, so 35 cos theta, and then here we have 35 sin theta. Alright, okay. Then next step what to do? Okay, next step, okay, kita akan total up. Okay, the components, right? So to total up the components, okay, net force along x, okay, we have okay, campurkan dua ni, alright. So we have 35 cos theta minus 20. Okay, by right, net force equals to ma, isn't it? Equals to ma because it gerak kan, ma. But okay, bear in mind, from the first sentence in the question, dia tulis kat sini constant speed. Right? So kalau constant speed meaning dia tak accelerate, isn't it? So A equals to 0. Right? So we can have that. Okay, gantikan A equals to 0 dekat sini. Right? So ni akan jadi 0. Right? So with that, can you find the theta? Yes. So 35 cos theta equals to 20. Ni buat jadi positive equals to 20. Then you can find theta, isn't it? Alright, so theta you akan dapat 55.2 degree. Yes? Okay. Okay, good question. Alright. Jadi kalau along x-axis dia bergantung kepada soalan. Okay, theta is given above the horizontal. Alright, so theta is above horizontal. Alright, so itu pada segitiga ni, above horizontal. Jadi dekat sini kita ada 35 Newton, isn't it? 35, right? So kalau along X component, this X di sini, Fx, Fy. Okay, bergantung kepada theta tu diberi dekat mana. Alright. So here the theta is above horizontal. Alright. So therefore kalau ikut max, okay. So dia adalah dia cos, isn't it? Alright. Fx over 35 equals to cos theta. Alright. Jadi here X komponen dalam sebutan cos. Okay, bergantung kepada theta tu diberi mana. Jangan hafal ya. Jangan hafal. Kalau X sentiasa cos, kalau Y sentiasa sin. No. Okay. Bergantung kepada theta tu diberi with what is this. Alright. Got it? Okay. Because sometimes theta ni, okay, nanti kalau soalan lain saya tunjuk mana satu yang apa. Kalau theta sin ni, okay, let's find out later. Alright, macam mana kalau theta, kalau X component dia sin. Okay, alright. So at the moment, okay, in this case, okay, untuk long X component is 35 cos theta. Alright. So when you calculate, you akan dapat theta equals to 55.2 degree. Right? Okay. Now, part C, what is the magnitude of the normal force that the ground exerts on the suitcase? All right. So to find the normal force, now we are going to solve yang Y component pula. All right, yang Y component. So we have in part C. Okay, in part C. Alright, so untuk Y component, we have the net force along Y equals to okay, normal force minus mg okay, plus 35 sin theta equals to 0. Kenapa equal to 0? Because there is no up and down motion of the force, isn't it? Okay, so you can find normal force n equals to, ini bawa ke sini jadi positif. So we have mg tolak, okay, 35, okay, sin theta dah dapat daripada part A 55.2 degree. Alright, ada tak dia bagi m? Yes. Okay, the mass is given just now, the mass of the suitcase. Alright, mass of the suitcase 20 kilogram. Right, so we have 20 kilogram. So we have 20, okay, 9.8, okay, minus 35 sin 55.2. Okay, then you get the answer, right? So the answer here is, okay, apa? 167. Okay, 167. Newton, isn't it? All right. 167 Newton. Now, many questions ask me, okay, G ni kenapa tak ganti dengan negative 9.8? Okay, GY tak ganti dengan negative 9.8. Why? Okay, because dalam free body diagram, in this free body diagram, kita dah, we have already indicate that mg is directed downward. Can you see this free body diagram? Mg is directed downward, and we already have put the negative sign here. Nampak ni? Here. Alright. Ni negatif ni. Okay. Right. So meaning you don't have to put again, once again. Kalau tak dah salah dah. Okay. So this is due to indicate that G is pointing downward. Alright. Okay, the same question. Okay, the same question. Okay, can kita nak cari work. Okay, find work done by every forces. Alright. So here we have how many forces do we have? Ini I nak cari additional question lah. I want to find work. Okay, from each of the forces. Okay. Sekejap ya, I will write here. Okay, the same question. The same question, but now I want to find work. Find work from all the forces, okay, from each forces. All right. So how many forces are there? Okay, here we have ada berapa forces? We have 35 Newton force, we have normal force, we have mg, and we have friction. Ada 4 forces, isn't it? All right, so let's calculate one by one. Okay. Now first, katalah I nak cari work done by normal force. Okay, work done by normal force sama dengan, alright. So generally we have apa tadi? Formula dia Fw equals to Fs cos theta, isn't it? Fs cos theta. Ini general equation. Okay. So kalau normal force, you have to substitute lah F ni dengan normal force, isn't it? Normal force. And then displacement S, okay, cos theta. Theta adalah, okay, sudut di antara displacement dengan normal force, isn't it? Alright. The suitcase is moving to the right. Okay, ni suitcase moving to the right. Normal force kat sini. So berapa angle dia? Daripada displacement ni 90 darjah je ni, 90 degree. Alright. So cos 90 equals to 0. So we get that the work from the normal force equals to 0. Alright. Second one. Okay, katalah you nak cari work done by friction force. Okay, work done by friction force. Jadi, okay, force kat sini adalah the friction force. Okay, and then displacement, and then cos. Okay, berapa sudut di antara displacement dengan friction force? Alright. So ni adalah displacement, friction force tu adalah dekat belah sini kan, isn't it? Ni friction force, ni displacement. So sudut dia 180 darjah, isn't it? Opposite direction. Okay, cos 180 degree. Alright, so friction force just now is berapa friction force tadi? 20, isn't it? 20, alright. So ni tak perlu letak, ni letak magnitude saja, right? 20 Newton, okay. And then displacement dia adalah, okay, displacement. Ada tak dia bagi displacement? Okay, in case lah, tapi because I just create this question. Okay, displacement. Okay, katalah dia berjalan sejauh, let's say dia bergerak sejauh 500 meter. Okay, alright. So let's say the woman is walking 500 meter. Alright. 100 meter, 100 meter lah. Let's say for I just want to add lah. Okay, sekejap ya. Find work from each forces if the woman is moving. Okay, if displacement is katalah 100 meter. Okay, let's say 100 meter. Right. So ni adalah 100. Okay. Cos 180 is negative 1, right? So we get apa ni? Negative 2000, isn't it? Negative 2000 joule. Right? Okay, number 3. Okay, now let us find work done by the force of gravity, mg. Right? So we have force dekat sini akan jadi mg lah, isn't it? Okay, mg, and then displacement, right? So the angle between the displacement and gravity is, okay, kalau you tengok dia punya ni adalah, okay, this is the displacement, mg is here, isn't it? Ni mg, betul? Alright, so the angle is 270 degree, alright? So ni cos 270, which also equals to 0. Equals 0. Right? And then work done by 35 Newton force. Okay. Work done by 35 Newton force. All right. So we have, okay, the fourth one. Work done by 35 Newton force. Okay, so we have the force has magnitude of 35 Newton. Okay, katalah dia bergerak sejauh 100 meter. Okay, 100 meter ni I just assume that the woman is walking 100 meter. Okay, and then we have cos. Okay, berapakah sudut antara 100 Newton antara displacement dan 35 Newton tadi? Cos berapa? 55.2, isn't it? Sorry, after cos 55.2. Okay, cos 55.2. Right, so you calculate and then you get the answer. Okay, so what do we have here? Okay, let me find out. Okay, cos 55.2. Okay, cos 55.2. Okay, times 100 times 35. So this one you will get 1997 joule. Right? So how to find the total work? Okay, this one. Okay, to find the total work, okay, so apply this equation. The net work ataupun the total work sama dengan the sum of all the forces. Okay, Wn campur dengan Wf campur dengan work done from the mg and work done by 35 Newton force. Just total up. Okay, so this will be 0 minus 2000, plus 0, plus 1997. So you get the total work. Right? Okay, let's try another question on how to find work. Okay. Okay, another question. Okay, a 2 kilogram box slides down a ramp a distance of 2 meters before it reaches the ground. The ramp has an angle of 30 degrees. The coefficient of kinetic friction for the ramp is 0.1. Okay. What is the work done by gravity on the box? Okay. Dalam question ni, in this question, there is no diagram. Okay. You have to illustrate by yourself. Okay. You have to draw by yourself. So how? Okay. Here the keyword is slides down a ramp. Okay. Meaning that this object is not moving horizontally, right? But it is sliding down a ramp. Okay. So let's try to draw. Before we draw a free body diagram, free body diagram is a must lah. Okay, in this question, free body diagram is a must. But before that, okay, just draw a ramp. Okay, a ramp. Okay, and the ramp has an angle of 30 degree. Okay, so this is 30 degree. Right? So the ramp a distance of 2 meters, meaning katakanlah dia start at the top here, right? So this is 2 meter. Going down, okay, going down, okay. And then the ramp has angle of 30 degree. The coefficient of kinetic friction, the friction is 0.1, okay. So we have mu k. As it goes down, it has kinetic friction, okay. And the coefficient of kinetic friction is given 0.1. Okay, what is the work done by gravity on the box? All right. So in this case, you have to draw a free body diagram. Okay, ni kita dah illustrate dah, right? So how to draw free body diagram? So we always choose, okay, the ramp, okay, yang ni, okay, garisan ni sebagai x-axis, right? So I want to draw a free body diagram. Okay, so first this will be the x-axis. Okay, ni x-axis. Kali ni x-axis dia bukan dalam bentuk horizontal line, right? We always choose the incline as the x-axis, right? And perpendicular to it is the y-axis, right? Perpendicular ni y-axis lah. Okay, y-axis. Okay. So this is y-axis. Okay, now let us put the vectors, okay, on the diagram. Okay, first we have, because it's sliding down, okay, kita akan cari all the forces acting on it, right? So kita ada mg, right? Of course, mesti ada mg, okay. And then it is the box is in physical contact with the surface, so akan ada normal force, isn't it? Right? So normal force, yang ni normal force, okay, always perpendicular with the surface, right? Normal force. And then what do we have? Kita ada friction, isn't it? Okay. So friction is always opposed the motion. Okay, the box is sliding down. Okay, so friction will be oppose the motion, right? So kita ada friction force kat sini. Okay, friction. So the box just slides down, isn't it? So tak ada external force yang tarik dia, ataupun there is no rope ataupun cable, okay, attached to it, right? So we have these three forces, okay. So all kita nak cari apa? What are you going to find? We are going to find the work done by gravity, isn't it? Okay, meaning nak cari work done by mg. Okay, so how to do? Alright. So we have to list down all the we have to divide. Okay, okay, the forces. Okay, walaupun nak cari work, but we still have to find out, okay, the net force along x and net force along y. Alright. So what do we have here? Okay, along x component. Okay, don't forget the table. Okay, so we have x component and y component. Okay, and here is y component. All right. In the x component, we have friction force, but it is directed to the left, so negative F, right? Now mg, this is 30 degree, so 30 degree, right, lies here. Okay, sama juga. So kat sini kita dapat 30 degree here, right? Di 30 degree. Okay. Now mg has two component, isn't it? mg has two component. Alright, so kita ada, okay, alright. So merujuk kepada soalan kawan you tadi yang kata theta apa, x component cos and all that, right? So nampak tak dia macam satu segitiga? Okay, so I lukis balik segitiga ni, alright. Okay, di mana we have something like this. Okay, so this is 30 degree, right? Okay, 30 degree lies here. And then mg kat sini kan, mg. Alright. So let us find out the component of mgx dengan mgy. So this is mgy. Ini adalah mgx, isn't it? Okay, mgx. Right, this is mgx. Okay, kali ni you nampak tak? mgx is opposite to the 30 degree. So now you have mgx, okay, over mg equals to sine 30. Isn't it? Equals to sine 30. So kali ni x component dia sine. Nampak tak? That's why I tak nak you hafal x sentiasa kena cos, okay, y sentiasa kena sine. No, alright. So mgx equals to mg sine 30. Got it? Okay, mg sine 30. Okay, so ini along x component, isn't it? So mana mgx? Ni mgx. It is directed to the right, isn't it? Okay, ke arah positive x. Okay, so I have dekat sini. So we have mg sine 30. Okay, for y component, okay, we have normal force, and then we have negative mg cos 30. Alright. Kenapa negatif mg negatif? Sebab y component dia ke bawah, isn't it? Y component dia ke bawah, mgy. Okay, and then add up. Okay, we are going to add all the components. Okay, so we have, okay, net force along x. Okay, net force along x. Okay, we have, okay, mg, okay, sine 30 minus friction force. Okay, friction force equals to, okay, dekat sini friction force dia tak bagi kan, dia bagi mu, but we know that friction force equals to mu n, isn't it? Remember, F equals to mu n, right? So minus, I buat sini mu n, okay, mu n equals to, right, ma, isn't it? Equals to ma. Kalau dia bergerak secara constant speed, constant speed, then we can substitute A equals to 0. Alright. How about net force along Y? Okay, net force along Y we have, okay, net force along Y we have N minus mg, okay, cos theta equals to 0 because there is no up and down motion. So we have N equals to mg cos theta. All right. Okay, actually we are just trying to find we are going down by gravity, isn't it? All right, but I am showing to you, okay, the forces as well, okay, because kalau nak cari work, okay, it's better for you to have the better understanding on how to define, okay, all the forces in the system, right? Okay, so back to the question, what is the work done by gravity? Okay, so to find the work done by gravity, we can have, okay, work done, okay, let me write here, okay. So the main question is the work done by gravity, okay, equals to, okay, generally we have, here work done by gravity, so the force related to here is mg, wait, so we have mg and then displacement and then cos theta, isn't it? Cos theta. All right, cos theta. So what is the mg here? Do we have m? M, okay, what is the mass here? Is the mass given? Okay, a 2 kilogram box. Okay, a 2 kilogram box. All right, so we have 2 kilogram. Okay, we have 2 kilogram box and then 9.8. The displacement is along here, isn't it? Okay, displacement kat sini, displacement, okay, dia bergerak sejauh apa meter? Sejauh 2 meter, alright, 2 meter, and then cos theta. Okay, theta berapa? Okay, theta ialah, alright, from here, ni displacement, okay, displacement, from here up to here. Okay, so berapa? I get 270 campur 30, isn't it? Alright, so we get cos 300. Cos 300. Okay. Why 300? Okay, nampak tak ni? Ni displacement ke arah sini. Ni displacement. And this is mg, right? Ni mg. Okay, ni 30. Okay, 30. Alright. So from here, okay, bila kita nak cari angle, biasanya kita mula daripada paksi x, daripada displacement ni. Okay, and then counterclockwise sampai dekat mg ni. That is 3, cos 300. Right? So here you get approximately 19.6 joule, approximately 19.6 joule ataupun 20 joule, right? Now from the same question, katalah you nak cari the work done by normal force. Okay, the work done by normal force. Okay, how? Okay, so to find work done by normal force, okay, I can write the additional question, okay. So to find the work done by normal force, okay, work done by normal force sama dengan, okay, the normal force, okay, and then displacement cos theta, isn't it? Alright, cos theta. Okay. So normal force mana? Normal force ialah this one, mg cos 30, isn't it? Okay, mg cos 30. Right? So just substitute, okay, mg, okay, cos 30, and then displacement 2 meter, and the normal force is making 90 degree with the displacement, isn't it? Cos 90. So the work done by normal force equals to 0. Right? In case you are asked to find the work done from the respective forces. All right. Okay, next, okay, I think it is enough for cost and work. Okay, so let's go through another topics. Okay. Okay, wait ya. Alright. Okay, conservation of energy. Alright. Okay. Okay, just to pick up some information on conservation of energy. Alright. Okay. Now, in conservation of energy, we know that energy cannot be created, energy cannot be destroyed, but it can be transformed from one form to the other form, isn't it? Okay. All right. Okay. There is two cases. Okay, two cases here. All right. Conservation of energy. All right. Okay. Conservation of energy. Okay. Now, basically, kalau conservation of energy, it means that energy must be constant, isn't it? Okay, the word conserved. Conserve means constant, right? So meaning to say energy is kept constant. Tu dia keyword of kataan conservation ni lah, right? Energy is kept constant, alright? Energy is kept constant, okay? Alright. Meaning to say, okay, okay, E initial, E at any point dia sama. Okay, meaning E initial sama dengan E final. Okay, so mathematically we can write E initial sama dengan E final. Meaning kita ambil 2 point je. Sebenarnya dekat semua point. Dekat semua point, energy tu sama value dia, right? But if I choose the initial point and final point, so this value will be the same. Okay, jadi E ni apa? Alright, E is the total of energies. Alright, E is the total of mechanical energies. Right, ini adalah total of mechanical energies. Alright, so what are the two mechanical energies that you learn? Only kinetic energy, okay, plus potential energy. Alright, jadi I can write, okay, KE, okay, plus PE. Now PE sometimes also can be represented by U, isn't it? Okay, dalam textbook, okay, potential energy is U, right? So KE plus U I sama dengan KE, okay, plus U final. Okay, ataupun I can also write KI plus UI, okay, equals to K final, okay, plus U final. Okay, I can also write it as K final tolak K initial sama dengan K final tolak U initial sama dengan U initial tolak U final, ataupun delta K sama dengan ni negatif U final tolak U initial kan, isn't it? Okay, sebab I nak apa, because bila kita nak cari change, the change ni is always final tolak initial, isn't it? Ataupun I have delta K plus delta U equals to 0. Right? So this is conservation of energies mathematically. Right? So we can express it mathematically by this expression. Okay, but we can use delta K plus delta U equals to 0 if there is no friction. Okay, frictionless. Dalam keadaan tak ada friction. Okay, meaning we can use this one if there is no friction. Okay, frictionless. Okay, frictionless ataupun there is no air resistance. Alright. Okay, no resistance and so on and so forth. Okay, no air resistance. Right? Okay. But if we do have resistance, what can we use? Okay, kalau ada resistance, okay, we can apply. Okay, ni buat satu garisan. Okay. If there is friction, okay, if there is friction, then this equation will become, dia tak lagi sama dengan kosong, tapi dia akan sama dengan apa? Delta K plus, okay, delta U akan sama dengan work done by friction. Okay, work done by friction ataupun okay, ataupun kalau dalam textbook, okay, dia tulis delta INT, isn't it? Alright. So delta K plus delta U. Okay, okay, we have something like plus delta EINT, okay, equals to 0. Right? So ni meaning ada banyak form untuk kita nak cari. Alright? So yang paling senang ni lah, delta K plus delta U equals to work done by friction. Okay. The change, okay, dalam textbook you ada nampak ni kan, the change in the internal energy, right? Okay, the change in internal energy. Okay, this one sama juga dengan work done by friction. Okay, the change in the internal energy ni sebenarnya sama dengan work done by friction, sama je. Okay, it is equal. Okay, and to find the change in the internal energy, dia sama dengan apa? Sama dengan kalau tengok dekat textbook, okay, sama dengan mu, okay, F sama dengan okay, FFW, FD, okay, FD, alright, okay, okay, sama, okay, ni pun sama jugalah, meaning work done by friction sama dengan FD, alright, ni pun you kena ingat jugalah, okay, alright. Now let's go through some questions on how to apply all this conservation of energy. Okay. Okay, dekat sini kita ada spring. Okay, we have a spring. Now kalau spring je, terus ingat dalam spring we have spring potential energy, right? Given by U equals to half K X squared, right? Okay, let's go through this question first. A block of mass 3 kg is placed against a horizontal spring of constant K equals to 875 Newton per meter and pushed so the spring compresses by 0.07 meter. Okay, again, question ni tak ada gambar rajah tapi kita try, okay, to illustrate. Okay, so kita ada horizontal surface, right? And then we have a block of mass 3 kg. It's placed against the horizontal spring. Okay. Alright, mana spring? Okay. Okay, wait, I nak buat macam ni. Okay, wait ya. Okay, something like, okay. Ini spring. Okay, we have a spring here. This is a block. Okay. So this block is 3 kg. Okay, it's placed against a horizontal spring of constant. Okay, K equals to 875 Newton per meter. 875 Newton per meter and pushed, so the spring compresses. Okay, so maksudnya kita apply external force. Okay, bila dia kata perkataan pushed, maksudnya ada external force, isn't it? Okay, ada external force so that the spring compresses by 0.07 meter. Okay, jadi dibagi delta X lah. Okay, displacement of the spring. The question is, what is the elastic potential energy of the block spring system? Okay. Nak cari elastic potential energy U. We are going to find U here. Okay. Alright. So how? So to find the elastic potential energy, okay, so we have U equals to half kx squared, isn't it? Half, okay, k x squared. So when it is compressed by 0.07, okay, nak cari dia punya elastic potential energy. So U equals to, this substitute, okay, half K is 875. Okay, X is the displacement, isn't it? So dia dah displaced banyak 0.07 square. Okay, 0.07 square. Alright. So can we calculate? Right, so let me calculate first. Okay, so we have 0.5 okay, times 875 okay, times 0.07 okay, times 0.07. So we get 2.14 joule. Alright, so the part A. Okay, part B, if the block is now released and the surface is frictionless, calculate the block speed after leaving the spring. Okay. Is now released. Okay, in order to release, kita kena compress dulu, betul tak? Okay, meaning the initial, okay, I nak make it like initial dulu, right? So what do we have here? Okay, wait. Kalau ada spring, it is important for you to know apa your initial, meaning that initially dekat mana block tu. Okay, you have to find out. Okay, so initially dekat mana? Push, so the spring compresses by 0.07, meaning initially it is being compressed, isn't it? Meaning to say, okay, initially they're being compressed. Okay. Being compressed, so katalah dekat sini. Okay. Katalah mula dia dekat equilibrium position. Okay, mula you compress dulu. You compress dulu sampai dia dekat 0.07. Okay, so here we have X equals to, sebab dia compress, so ni negatif lah, 0.07 meter. Right. So lepas dia compress, okay, if the block is now released, meaning you compress dulu, lepas tu baru you release. Bila release, bermaksud dia akan going to the other side, isn't it? Dia release. Betul? Right? Release. Calculate the block speed after leaving the spring. Alright. So how? Is now released and the surface is frictionless. Okay. So keyword dia dekat sini adalah release dan surface is frictionless. Alright. So initial dekat sini, final dia calculate the block speed after leaving the spring. Alright. So how? Dekat sini kita boleh apply delta K, okay, plus delta U equals to 0, isn't it? We can apply the, what you call it, conservation of energy. Because it is frictionless, then this one must be equals to 0 lah, isn't it? Equals to 0, right? So this is K final, okay, minus K initial, okay, plus, okay, U final minus U initial. So what assumption to be made? Okay, dekat sini, we only have spring potential energy. There is no gravitational potential energy, right? So finally, K final, okay, okay, wait, yeah, push the spring, okay. calculate the block speed after leaving the spring. Okay. So initially, okay, kita compress. So dekat sini, kita kata apa? V dekat sini equals to 0, isn't it? UI, okay. Meaning kat sini K sama dengan kosong. Bila initially kita compress. So Ki equals to 0, isn't it? Alright. Finally, barulah dia gerak, isn't it? So initially, there is no kinetic energy of the block, isn't it? So kita nak cari, okay, half mv squared as it leave, right? Plus dengan, okay, as it leave the spring, okay, dia dah tak ada potential spring potential energy, isn't it? So dia akan jadi kosong finally, right? Plus dengan half, so dia akan jadi negative half kx squared, isn't it? Kx squared equals to 0, right? So meaning to say, ki equal to 0, u final equal to 0, isn't it? Bila dia leaving the spring, kita tak kisah dia leaving kat mana pun, alright? As long as dia dah tak connected to the spring, so there is no spring potential energy, alright? So we have, so we have v squared equals to, okay, rearrange the equation, k over m x squared. Alright, so initially it is being compressed by 0.07 squared. Alright, so can you find the speed? Yes, right. K dibagi, K is 875. Okay, let me check. 875 divided by mass is 3 kilogram. Okay. Okay, times, okay, 0.07. So we get 1 point. Okay, punca. Okay, punca. Okay, 1.2. Okay, ataupun 1.8. Okay, jangan lupa puncakan. Alright, so you get approximately 1.2 meter per second. Right? Okay. Okay, another question on conservation of energy. Alright. Okay, a skier starts from rest at the top of a frictionless incline of height 20 meter as in the figure. At the bottom of the incline, the skier encounters a horizontal surface where the coefficient of kinetic friction is 0.21. Okay, so in this question, okay, yang bahagian ni tak ada friction. Okay, kat sini meaning to say, dekat bahagian incline ni, no friction. Alright, so there is no friction here. Yes, ini no friction. Okay. At the bottom ada friction. Okay, kat bawah sini ada friction. Okay, where the mu is given here 0.21. Alright. Okay, so the question is find the skier speed at the bottom. Okay, kat the bottom maksudnya nak cari speed of the skier dekat sini. Alright, ni nak cari berapa speed dia. Okay, alright, so how? Okay, so to find the speed, we are going to apply conservation of energy. Alright. Now, bila nak guna conservation of energy, okay, kita tulis dulu. Delta K plus delta U equals to 0. Alright. So dekat sini I have mentioned to you, you kena cari point awal dan point akhir, isn't it? Alright. So ni K final tolak K initial. Okay, plus, okay, yang the other one, we have U final minus U initial. Okay, equals to 0. Alright. So dekat sini, we are going to find the skier speed at the bottom. I nak choose these 2 points, meaning initially at point A, finally at point B. Alright. So I want to rewrite the equation as, okay, finally dia dekat point B, and then initially dia dekat point A. Okay, plus dengan U final, okay, meaning initially at point B and then initially at point A kan, initially at point A equals to 0. Alright. Now, at the question here, a skill starts from rest. Okay, a skill start from rest, right? Jadi kalau starts from rest, meaning the kinetic energy at A equals to 0, right? So we have kita nak cari speed at B, isn't it? At B, okay, so we have half mvb, okay, vb squared, okay, minus 0, okay, minus 0, right, plus dengan, okay, now potential energy. Okay, potential energy adalah mgy, isn't it? Okay, mg, right, yb tolak ya. Okay, yb tolak dengan ya equals to 0. Alright. Jadi kita we measure the height, okay, from the ground, isn't it? From the ground. Okay, from the ground. Mana ground dia? Okay, ground dia kat sini. Okay, ground dia dekat sini. Maksudnya point B ni y equal to 0, betul tak? Alright. So ni y equals to 0. So meaning we have that. Okay, okay, we have okay, half mvb squared, alright, plus dengan, okay, mg, ni b tau, okay, ni b, okay, mg, and then 0 minus ya. Okay, dia dah bagi A ni adalah 20 meter, isn't it? Alright, height at point A 20 meter. So kosong minus 20 equals to 0. Right, what can be cancelled here? Mass can be cancelled, isn't it? Mass can be cancelled. So can you find the speed? Yes, right. So the speed at point B equals to, alright, ni bawa ke sini jadi tak apa, okay. Half VB squared equals to, this is 20, ni bawa ke sini positive, 20 and then 9.8. Alright, then you can find the speed at the bottom, isn't it? Alright, which you will get 392 okay, 392. Okay, 392 meter per second. Okay, B, how far does the sphere travel on the horizontal surface before coming to rest? Neglect and resistance. Alright. Oh, ni half VB squared. Sorry. Ni VB. So, punca kuasa. Okay, punca kuasa. Almost 20, isn't it? 19.7. So, this is 19.7. 0.7 meter per second. Okay. B, all right, how far does the sphere travel on the horizontal surface before coming to rest? Okay, the word before coming to rest bermaksud at point C ni V dia equals to 0, isn't it? All right, so here VC equals to 0, right? So how far? Nak cari displacement D, right? So here we are going to find D, and don't forget we have friction there, okay, ada friction. Jadi, we may also apply delta K plus delta U, right? So, this will be, okay, dekat sini sama dengan work done by friction, isn't it? Because now we have friction, okay? So, delta K, now I am going to choose point C dengan point B, right? Ni point C, ni point B, isn't it? Okay, ataupun, okay, or, okay, okay, tak apa. Okay, we have half, we have K final, K at point C minus dengan kinetic energy at point B, right? So dekat sini, there is no potential energy, isn't it? Because it is horizontal surface. So ni kita boleh ignore lah, alright? Equals to work done by friction. Okay, work done by friction sama dengan F D cos theta, isn't it? Cos theta, right? So kinetic energy at point C equal to 0 because of the word before coming to rest is okay, minus okay half okay mv squared, okay, where we know already the speed at point B, isn't it? 19.7 squared equals to okay, the friction force here equals to mu n, betul tak? Mu n kali dengan d, right? And friction force is opposite with the motion. Okay, so we have cos 180 degree, right? So what do we have here? Okay, just continue. Okay, so we have half okay m v squared. Okay, just carry on. Okay, with half mv squared equals to mu is 0.21. Okay, 0.21. Now, since it is a horizontal line, okay, so normal force is balanced by mg, isn't it? Is balanced by mg, and then d, all right, cos 180 equals to negative 1, right? So what can be cancel here? Kita boleh cancel mass, and then kita boleh cancel negative 1, right? Negative 1. Okay, so can you find D? Yes, right? So ni kita ada okay, half okay 19.7 squared, right, equals to okay, gantikan G with 9.8, right? 0.21, okay, G is 9.8. Lepas tu D, which is the displacement lah. Alright, so can you find D? Yes. Alright, so D ni you akan dapat. Okay, let me calculate. Okay, 19.7. If the block is pulled out to 0.05 meter and released, find the speed of the block when it first reaches the equilibrium point. All right. Okay, so let us draw once again. Now, in this diagram, it states and then we have the weight mg, okay, and then kita ada friction, okay, and then we have the external force, right? If the block is pulled out at initial 0.05 and released, right? So here we are going to find out, okay, dekat mana dia, okay? So untuk diagram untuk part A, okay, okay, katalah, okay, let's say first we have the spring, okay. Okay, kata ni keadaan asal, kita tak buat apa-apa pun lagi, okay, the block is attached to the spring, okay. Okay, now if the block is pulled out to xi equals to 0.05, meaning initial condition dia ialah okay, Okay, sekejap. Okay, let me draw properly. Sekejap I draw properly. Okay. Okay. So katalah, okay, let's say first kita ada, okay, this is the block. Okay, let's say pada keadaan asal, we don't do anything. The block is attached to the spring. Okay. Okay, this is, let's say, the equilibrium position. Alright, so ni katalah x equals to 0. Tak buat apa-apa pun lagi. There is no external force acting on it initially. Alright. And then if the block is pulled out to xi equals to 0.05, meaning kita tarik spring ni. Alright, tarik spring ni. So we pull it with external force lah. Alright, external force Fs katakan. Okay, kita tarik sejauh berapa? So kita tarik dia sejauh kata sampai kat sini. Alright. So let's say here is x equals to 0.05 meter. 0.05. Alright. So kita tarik sampai kat sini. Alright. So this will be at t equal to 0 dekat sini lah. Alright. Tarik and then kita release. Right. So bila kita release, of course, dia akan go to the other side, isn't it? Okay, meaning that katalah at t equal to 0 kat sini. So bila kita release, okay, so meaning the spring force is now going to the left, isn't it? So bila kita release, dia akan going back to the equilibrium position, and then dia akan go back to the other side, isn't it? At x equals to negative 0.05, betul? Alright, so this is the initial condition of the spring. Okay, so the question is find the speed of the block when it first reaches the equilibrium point. So meaning bila kita dah release, dia pun akan travel, dia akan pass at x equal to 0, isn't it? So nak tahu okay, berapa speed dekat sini. Alright, so what is the speed here when it first reaches the equilibrium? Alright, jadi initially okay, x equals to positive 0.05 meter. Okay, so meaning that the 2 point that I want to choose here is at x equals to 0.05 and finally at x equals to 0, isn't it? When it first reaches equilibrium, right? Okay, jadi to find, okay, this frictionless, isn't it? Frictionless. So to find the speed of the block by using conservation of energy. Okay, that is, all right. So we have, apa dia formula tadi? Okay, delta K, K plus delta U equals to 0. Alright. So ini adalah K final, tolak K initial. Okay, plus, okay, U final minus U initial equals to 0. Right? So mana final point, mana initial point? Okay. So final point dia dekat equilibrium position, right? Okay, dekat equilibrium position. Okay, at x equal to 0. So dekat sini kita nak tahu berapa dia punya speed, isn't it? Alright, half m v squared. Kinetic energy equals to 0, isn't it? Alright, because dekat sini kita tarik and then kita release, isn't it? So dekat sini k equals to 0. Alright, and then plus, okay, finally dia dekat equilibrium position, right? Okay, so dekat equilibrium position, x equals to 0, isn't it? So dekat x equals to 0, u sama dengan kosong, right? Okay, u sama dengan kosong because u equals to half kx squared, isn't it? Half kx squared. So when x equals to 0, jadi u pun sama dengan 0, isn't it? Okay, back to the question. Okay, just now, technical problem. Okay, sharing apa. Alright, back to this one. Okay, I repeat once again. Alright. So your final okay, can you hear me? Okay, okay. Alright. So dekat mana kita stop tadi? Okay. So I just repeat part B. Okay. Alright. Um, now in part B, we are going to find the speed when x uh, sorry. Okay, so in part A, we are going to find the speed of the block when it first reaches the equilibrium point, isn't it? So in part A, the 2 points that I am going to choose is per point x equals to 0.05, which is the initial point, and the final point that I want to choose here is the equilibrium point, that is x equals to 0. All right. So I am applying conservation of energy where delta K plus delta U equals to 0. Why 0? Because it is frictionless, isn't it? Right? And then I kembangkan this equation. So we have that the final kinetic energy is half mv squared. Dekat mana? Dekat sini lah. Right? At equilibrium position. KK dekat sini. Right? And then initially the kinetic energy equals to 0. Right? Meaning at the first point dekat 0.05 meter, alright, ataupun dekat maximum displacement, right? Okay, finally it is at half k at x equal to 0, alright. So when u equals to half kx squared, when x equal to 0, so u equals to 0, isn't it? So ni gantikan dengan kosong, minus, okay, initially it is at half kx, x is 0.05 squared. All right, equals to 0. Okay, So by substitute, okay, half mv squared equals to, ni bawa ke sini jadi positif. So half k kita ada, k is 400 given in the question. Alright, in the question dia ada spring constant of 400 Newton per meter. Okay, half, okay, so we have 400 and then 0.05 squared. Okay, mass is given. Okay, mass substitute with 5 kilogram. Then you can find the speed, isn't it? All right. So you have B. Then you can find the speed. Okay, at equilibrium position. All right. So gantikan mass dengan 5 kilogram, isn't it? All right. So here you will get, okay, okay, you calculate with the 400 times 0.05 times 0.05. Okay, divide by mass is 5. Okay, 0.2. I get 0.45. Okay, part B, find, so here I get 0 meter per second. Part B, so in part B nak cari V at 0.025 meter. Okay, so 0.025 tu dekat sini, somewhere around sini. Okay, so how to find it? Right, so dekat sini meaning with kinetic energy tak kosong lah, isn't it? So katalah ini point, I nak ambil point ni, right? So I have, okay, K at 0.025, okay, minus K at 0.05, okay, plus dengan U final, okay, U dekat 0.025 minus dengan U dekat 0.05. So this one will be equals to 0, right? Jadi we just substitute, okay, half M is berapa kilogram tadi? 5 kilogram, isn't it? Okay, just now we have okay, 5 kilogram object, right? So half, okay, 5, okay, 5 V squared. So ini, alright, V squared, okay, minus, right? So yang dekat sini kita tahu dia punya apa, 0, isn't it? Alright, initially K equal to 0, right? Okay, plus, okay, yang ni you have half K X squared, okay? So dia akan jadi 0.025 squared minus, okay, 0.05 squared equals to 0, right? So this one I want you to calculate by yourself, right? So ni boleh dapatlah V, okay, K kita tahu, gantikan K and you can find the speed at 0.025 meter, okay? Now part C, what are we going to find in part C? Okay, see, repeat part A if friction acts on the block with coefficient 0.15. Okay, kalau ada friction, if there is friction, okay. Repeat part A if there is friction, okay. So kalau ada friction, we just add, okay, dekat mana nak add? Okay, kalau ada friction, we have delta K plus, okay, delta U equals to work done by friction. All right, work done by friction. So we have, okay, so we have that delta K, meaning the same equation is used in part A, but you have to equate it with work done by friction. All right, which is, okay, half mv squared. Okay, I am using the equation from part A, right? Minus, okay, minus half K 0.05 squared equals to work done by friction, that is FD cos theta, isn't it? FD cos theta, right? So we have half, okay, M is 5, okay, V ni dah cari V yang lain lah, isn't it? Because kalau ada friction, V dia dah tak sama, right? If there is friction, then we have different V, isn't it? Okay. Okay, if friction acts on the block, right? So we have half mv squared, okay. All right, so we have, okay, minus, okay, half K is given, K berapa K? Alright, K nanti substitute sendiri, alright, K, and then 0.05 squared, alright, equals to, okay, so friction force equals to mu n, isn't it? Okay, mu n, okay, mu n, and then mu dia bagi, okay, mu dia bagi, and we are going to replace it with n equals to mg, alright, cos theta, alright, cos 180, because friction force is opposite displacement. Alright, so is mu given here? Yes, mu is given. Alright, mu ada. Okay, let me check. Okay, berapa mu dia tadi? Okay, mu is 0.15. Right. So kalau ada friction, dia tambah je. Okay, the equation will be apa? Delta K plus delta U equals to work done by friction. Okay, just equate. Alright, and then F equals to mu, mu dia bagi. Alright, M ada. Okay, G ada. Cos 180 is -1. Okay, K ada. Yes, K ada. Then you can find the speed, isn't it? Alright. So bear in mind, if you want to check the value of V, kalau ada friction, okay, V dekat part C ni must be V dekat jawapan V untuk part C mestilah less daripada speed that you get in part A. Alright, because when we have friction, okay, when we have friction, normally dia akan slowing down. Alright. Okay. Can you hold on for a minute? Okay, wait here. Yes. 5 minutes, 5 minit sekejap, 5 minit. Okay, on mic ya. Oh.
We will take a break for 5 minutes.
Continue.
Yeah, sure, madam.
Dengar tak Akmal?
Dengar, madam.
Okay. Alright. Okay. Alhamdulillah dengar. Okay. So nampak screen ya? Okay, now let us summary. Okay, very good. So ni madam nak summary pula untuk topik momentum and angular momentum. Alright. So momentum, okay, we have linear momentum, indicated by symbol P, and we have angular momentum. Right, remember angular momentum? Okay. Linear motion, kita tahu linear untuk gerakan yang sama ada along x-axis ataupun y-axis. Angular quantities means refer to object that is moving in circular motion, right? Now, in momentum, we have conservation of momentum, right? So in your textbook dia pecahkan conservation of momentum ni ikut situasi, sama ada situasi tersebut adalah isolated system ataupun non-isolated, right? Kalau isolated system means sistem yang tak ada daya luar bertindak ke atas dia, alright? That is isolated, alright? Meaning dia terpencil, right? Kalau non-isolated ada daya luar. So that's why you have F delta T equals to delta P. So ini adalah impulse momentum theorem, right? So bila masa nak pakai impulse momentum theorem, bila wherever we have force acting in the system, right? So bila masa nak pakai delta P, okay, this is the where the momentum is conserved, isn't it? Okay, ini especially dalam isolated system, right? Now, sama juga kalau dalam angular motion ataupun dalam circular motion ataupun rotational motion, right? So kalau dalam isolated system, okay, conservation of angular momentum, ini angular momentum lah will become ni Li omega I equals to L final omega final, alright? So ni kita pakai kalau sistem tu isolated. Contoh dalam bila you pakai naik merry-go-round, right? When you main merry-go-round kan, is it? And then ataupun blender, alright? Okay, pusing, right? Okay, and kalau non-isolated, okay, tak boleh pakai ni, alright? Kalau non-isolated, we have that torque delta T equals to delta N. Okay, so you nampak tak? Okay, dia tally tau. When you compare equation untuk linear quantities dengan angular quantities, okay, F ni setara dengan torque, isn't it? F setara dengan torque, alright? And then delta T lah. And the change in the linear momentum sama dengan the change in the angular momentum, alright? So dia tally, isn't it? Meaning kalau linear quantities F, kalau angular quantities torque. Kalau linear quantities, delta P. Kalau angular quantities, delta L. Alright, so it must be tally lah, okay. And note that, okay, also can so out of lines, right? Momentum usually and Okay, can you hear me? Akmal? Okay. All right. For elastic, we have how to distinguish between elastic and perfectly inelastic collisions. All right. Kalau if elastic collisions, okay, objects they have their own velocities after collision. All right. They have own velocities after collisions. All right. If perfectly inelastic, the two objects will stick together after collisions. All right. So in elastic collision, we have this equation m1 u1 k plus m2 u2 equals to k m1 v1 k plus m2 v2. Right. If perfectly inelastic, we have m1 u1 k plus m2 u2 because they are combined after collision. Then we have m1 plus m2 v. Right, these are the difference. Okay, the other difference between elastic and perfectly inelastic, okay, is that, okay, kalau elastic collision, kinetic energy is conserved. Right, kinetic energy is conserved. All right. For perfectly inelastic, kinetic energy is not conserved. Right. Here we have a not conserved. Okay, the other thing that you need to know, all right. Um, okay, the other thing that you need to know is that kalau you nak apply the kinetic energy punya concept dalam elastic collision, we have the you ingat tak? Okay, kalau kinetic energy conserved, meaning you have half m1 u1 squared plus half apa nama ni m2 u2 square equals to half m1 v1 squared and so on and so forth, isn't it? All right, but this equation can be simplified. It can be simplified by only by remembering this equation, meaning it can be simplified by this expression. Okay, you just remember this. Okay, okay. So instead of tulis panjang-panjang half m1 u1 squared blah blah blah, okay, so it will become u1 minus u2 equals to negative v1 minus v2. Alright. Ini simplification of the conservation of kinetic energy. Right? Ingat ni. Okay. And then for perfectly inelastic, they stick together after collision, kinetic energy is not conserved. Right? So biasanya kalau dalam perfectly inelastic, kita akan cari the loss of kinetic energy. Right? Berapa jumlah kehilangan kinetic energy. Okay, that is usually asked lah, okay, in perfectly inelastic collision, right? So let us try some questions, okay, on collisions. Okay. An object of mass m move to the right with speed v. Okay, ni katalah we have object with mass m, okay, ni m, move to the right dengan speed v. Okay, katalah dia speed dia v. It collides head on with an head on. Collides head on bermaksud macam ni, alright? Meaning the other object, okay, right? Kepala. An object of mass 3m with speed v over 3. speed yang sama dengan objek 1 tapi 1/3 daripadanya. Alright, 1/3 of the speed. Meaning kalau dekat sini katalah 9 meter per second, jadi akan jadi 3 meter per second. 1/3 of it. Alright. Now, if the two objects stick together, what is the speed combined? What is the speed of the combined object of mass 4m after collision? Meaning dia akan combine together after collision. Okay, so ni m, ni 3m combine. So nak cari berapa speed dia. Alright. Jadi we can apply the conservation of conservation pula. Okay, this is perfectly inelastic, isn't it? Perfectly inelastic. So we write first the conservation of momentum, m1 u1, okay, plus okay m2 u2 equals to, sebab dia stick together after collision, m1 plus m2 v, isn't it? m2 v, right? So m1 adalah m, okay, dengan initial dia adalah v plus or v over 3. Alright, v over 3. And then when we combine, dia akan jadi berapa mass dia? 4m lah. Okay, 4m. Lepas tu kat sini, I namakan ni sebagai v prime lah. Okay, v prime. Okay, because kita nak cari speed of combined mass kan, v prime, isn't it? Okay, so we have what can be cancelled here? Okay, ni 2mv, isn't it? Okay, 2mv equals to, okay, 4m v prime. Okay, so m can be cancelled, n can be cancelled. So v prime equals to 2 over 4 v ataupun v over 2. Alright. Okay, so the answer is B. Okay, the same question, okay, macam mana kita nak cari the loss of kinetic energy? Because kita tahu it is perfectly inelastic, okay, mesti ada kehilangan tenaga kinetik, isn't it? Alright, so let us find the loss of kinetic energy, right? So we have that initial kinetic energy. Kita kena cari dulu initial kinetic energy will be the sum of the kinetic energy of mass m, okay, plus dengan kinetic energy of the second mass, that is 3m, isn't it? Betul? Right. So we have, okay, half m v squared, alright, plus dengan, okay, half, okay, the other one has 3m, isn't it? Okay, 3m, v dia adalah 1/3 of it, isn't it? v over 3 squared. Alright. So you calculate this one. Okay. And then you have KE final equals to, okay, hold on. Okay, equals to, okay, yang ni kita solve this one, we will get, okay, ringkaskan ni. Okay, ringkaskan ni, you akan dapat, okay, wait okay, let us simplify this one, okay. So we have half m v squared, right? Plus dengan, okay, ni 3 kuasa 2, 9, okay, 9, alright, 3 per 18, okay, m v squared, alright. Okay, so ni 9, 2 kali 9, 9, 12 per 18, alright. So I get 12 over 18 mv squared, isn't it? Alright. Samakan pembawah, okay, ni 2 kali 9, 1 kali 9, alright, 12 per 18. Okay, ataupun bahagi 3, 12 bahagi 3, 4. Berapa 6? Nah, 12 bagi 6. 12 bagi 6 2, 18 bagi 6 3, alright. So you get 2 over 3 mv squared. Just simplify it, okay. Now, how to find KE final? Okay, so to find KE final, okay, so we have, okay, nak cari KE final dia pula. Alright, so KE final sama dengan half mv squared, ni formula. Alright, so finally they are combined, isn't it? Okay, so we have that the total mass is 4m. Okay, and we know that the speed is v over 2, right? Okay, v over 2 squared. V over 2 squared. Alright, so here we have simplifikan 2m ni v kuasa 2 per 4. Alright, so we have 2 bagi 4 setengah. Okay, so half m v squared. Okay, ni final kinetic energy. Alright, so how to find the loss of the kinetic energy? Okay, so the loss ataupun the change in the kinetic energy will become, okay, so we have delta KE. Okay, delta K sama dengan K final minus K initial. Alright, sama dengan, okay, half mv squared minus, okay, 2 over 3m v squared. Alright, ataupun 2 bagi 3, 6, 6. Okay, 3 per 6 samakan pembawah, 3 per 6 tolak dengan, okay, 3 kali 2, 6, 2 kali 2, 4. Okay, 4 mv squared. 3 tolak 4, negatif 1 over 6. Right. So the change of the kinetic energy, it shows that if there will be loss of kinetic energy, and the loss of kinetic energy, right, basically, okay, itu sound, okay, and so on and so forth. Alright, dia tak ada form. Alright. Nampak tak? Soalan dia pendek je tapi banyak kita boleh tanya. Alright, we can ask about okay. So for the rest of the topic, okay, kita akan sambung pukul 2:30. Okay, so with that, Assalamualaikum warahmatullahi.
Thank you, Madam Sharifah, for delivering such an amazing lecture. Brothers and sisters, that marks the end of our session 1 of the event. Everyone may scan the QR provided for attendance for session 1. Now it's time for us to take a break before we begin session 2. Everyone, please be aware we're gonna start second session at 2:30 p.m.
الهنا أشفى جميلة شرف فؤادي وأنسى بها فرحان عادف علينا ليالي الجميلة بين القمر والغود والحدود الأصلية والغم والهنا أشفى جميلة شرع فؤادي وأنسى بها فرحان والغم والهنا أشفى جميلة شرع فؤادي وأنسى بها فرحان وحدنا دندنا وحدنا دانا وحدنا دندنا وحدنا ودندنا وحدنا دندنا وحدنا دانا وحدنا دندنا وحدنا ودانا وحدنا دندنا وحدنا دانا